go over A85 wave equation. This is the best video in wave equation. Not only wave equation, this is the best video in trigonometry. If you pay attention, this video will change your life because this is #1 video in this topic. We're going to start our conversation with a very simple fact that pulse versus waves. If you have a rope, if you do move it up and down, so it creates a pulse, right? This is a pulse. Pulse is non-periodic. However, if you move it up and down continuously, it's going to create a wave, periodic. All right, we're going to talk about two types of waves. Needs medium. Electromagnetic waves needs no medium. Medium, what can be a medium? Medium can be in the air. All right. So what would be the example of mechanical waves? Example of mechanical waves could be water or sound. What could be the example of electromagnetic waves? Example of electromagnetic waves, light, visible or invisible light. If I'm making this communication on the moon, right, speaking to you with same type of decibel, you would not be able to hear me because there is no air in the moon. So it is obvious that you need air, right? So sound uses air as a medium to move from one location to other location, to move from my mouth to your ear, for example. Light, on the other hand, if I shine a light over here, you would be able to see it. You would be able to see it on the moon if I shine a light, because light again needs no medium. Light can shine anywhere, even in the vacuum. Okay, so today we're going to pay attention to mechanical wave, right? So let's pay attention. Mechanical wave. Mechanical waves are two types: transverse and longitudinal. Transverse wave moves perpendicular, right, with respect to the direction of the wave, and longitudinal wave moves parallel. All right, the longitudinal causes the medium move, right? A medium can be a slinky, right? A medium make of particles, right? And the particles oscillate parallel with the direction of the wave. Okay, and when we talk about wave can carry energy, info, and mass. Absolutely no. Wave can only carry the energy and information, but not mass, right? Now we're going to dive deep into the transverse wave and longitudinal wave. What I want you to do, I want you to draw a transversal wave, right? A transverse wave. I want you to draw a transverse wave using a rope which is 20 meters long, right? And whose wavelength is 5.7 meters, right? Okay, so go ahead, pause the video and construct a transversal wave using this information. Amplitude, you can use amplitude 3 meters, right? Okay, so let's do it. Okay, so how many cycle? All right, let's find out. Cycle. How can you find the cycle? 20 divided by 5.7, 3.5. So 3.5 cycles. One cycle. 5.7. Two cycle. 11.4. 3 cycle. 17.1. and 3.5 cycle. 20 meters. What other information I should put? I should put the amplitude 3 and -3. What other information I should put? By the way, this is amplitude from equilibrium to the max height, right? From equilibrium to max height is the amplitude. From equilibrium to the mean height is also amplitude. So if this is 3, this has to be 3. Amplitude always absolute value. So you cannot say -3. Amplitude is 3. What other information I have to give you? Oh wow, we're going to write an equation. So y, this function takes position as an input. Okay, this function is a sine because this is just from 0, sine. This function has an amplitude 3. This function, just like all function, trigonometric function, is one cycle is 360 degree, which is 2 pi. This function has a lambda from crest to crest, or from trough to trough, or from 1 to here. So how many lambda over here? 1, 2, 3, 3.5 lambda. So in this wave, how many lambda? 3.5. Good. If you have a 3.5 cycle, you have a 3.5 lambda. 3.5 lambda. Okay. And this function takes x as an input. So this is a long transversal wave with a rope that is 20 meters long. Okay, now let's go over longitudinal wave. Longitudinal waves. Okay, so let's use a slinky. Let's say 5 meter long slinky. Okay, and I want to give you lambda. Lambda is, let's say, 2.5 meter. Okay, I want you to draw the longitudinal wave, right? So let's draw it. This is called compression. This is like, I'm going to draw, later I'm going to draw the transversal wave on top of this one. And this is like rarefaction. And this is compression again. And this is rarefaction again. And this is compression again. Okay, this is compression, this is rarefaction. Okay, so from compression to compression is 1 lambda, and lambda is in this case 2.5. So here lambda is 2.5. So 2.5 meters. From here to here is another lambda. Another lambda. So it's 5 meters. Okay? This is called crest. This is called trough. This is lambda. Okay, you see them on top of each other. Okay, so number 1, amplitude. Amplitude is max minus mean divided by 2. Number 2, vertical shift. Max plus mean divided by 2. Number 3, wavelength, which is called lambda. Distance over cycle. Number 4, period, which is time over cycles. Number 5, frequency, which is cycles over time. Number 6, velocity, which is lambda and frequency. This one SI unit is meter. This one SI unit is meter. This one SI unit is meter. This one SI unit is second. This one SI unit is hertz. This one SI unit is meter per second. There is another equation for period. You can say 1 over f and 1 over frequency 1 over t. All right, and that take us problem number 6. Problem number 6, I'm going to give you 2 graphs, and you're going to be showing me your understanding. You're going to be converting them to equation, from graph to equation. Before you did equation to graph, now you're going to do graph to equation. 6a, give you 2 cycle, 1, 2 cycle. I'm going to give you height, I'm going to give you position, make your position 8. Number 6b, I'm also going to give you 4 cycle, 1, 2, 3, 4, but I'm going to shift it. I'm going to shift it. I'm going to shift the graph. So there will be vertical shift. I can give you some information. This is 8. Let us say this is -2. I can give you other information. Let's say this is 36 meter, and this is of course your height. Okay. All right. So let's do over here this one. This one I wanted to find the equation. So to find the equation, you have to find the lambda. So lambda is distance over cycle. Distance is 8 meter, cycle is 1 and 2. So lambda is 4 meter. So why this function take x position as the input. This function has an amplitude 3 sine 2 pi over 4, and this function takes x as an input. So you can put x and you can find y. Okay, good. That's it. This one we have to find the midpoint. We have to find the vertical shift. So vertical shift is max plus mean divided by 2. Max is 8 minus 2 divided by 2, which is 3. Amplitude is max minus mean divided by 2. Max is 8 minus 2 divided by 2, which is 5. So amplitude is 5. So this function also take x as input. We have to find the amplitude. Amplitude is 5. This is a sine function. This is shifted to how much? Vertical shift 3. That's why it looks like, it doesn't look like sine, but it is sine. How do you know? But cosine really looks like this. All right. So 2 pi over lambda. You have to find the lambda. So lambda is distance 36 over cycle. 1 cycle, 2 cycle, 3 cycle, 4 cycle. So 9. Okay, x. All right. So this is the equation for this. Now that takes us to 7. 7, I'm going to also give you graphs and you're going to convert to equation. But pay attention, this time I'm not going to give you the height versus position graph. This one I'm going to give you height versus time graph. Okay, height versus time graph. This is 7 A. I'm going to give you a graph, 4 cycle maybe. 1, 2, 3, 4. Let's say 3, and let's say 8 seconds. And let's say, oh, by the way, I have to mention that second. This is t, this is y. Okay? And this is 7b. Again, I'm going to give you 4 cycle. 1, 2, 3, 4. 1 second. And I'm going to give you 1, -1. This is -3. Okay, good. What else I'm going to give you? That's it. I want you to write the equation. To write the equation, you need y of x. This is sine. You need amplitude, 3 sine. All right, 2 pi over, you need period. Period is time over cycle. 1 cycle, 2 cycle, 3 cycle, 4 cycle. All right, 2 t. That's it. This one, y, x. By the way, this is not x and this is not x. Y, t. Make sure you pay attention. I'm making this intentional mistake so that you pay attention. Y t is equal to 1. You don't have to write 1. Sine 2 pi over t. T is 1 divided by 1 cycle, 2 cycle, 3 cycle, 4 cycle. 1 over 4 t. Okay, that's it. Now that takes us problem number 8 and 9 is a snapshot. I have a cosine graph, 1, 2 cycle, 3 cycle, 12 meter, let's say, 3, -3. I want you to write the equation, so let's go ahead and write the equation. Y x is equal to 3. This is cosine 2 pi. You have to write lambda, distance 12, 1, 2, 3, so 4, and this is x. All right, so this is done. Now number 9 would be a little bit more interesting. This is like a picture. If you go to ocean right now and take a picture, right, and bring it to home, you look at it, you're not going to be able to see what is happening in the ocean right now. You're going to see, looking at the picture, what happened in the ocean when you took the picture, right? This is going to be video version, right? You are taking the video, you are on the ocean taking the video, right? So this is going to give you all the information that you need. So let's see what I mean. Again, I'm going to use this, so I don't probably have to do that. I can use this space. Let's say this wave move with 0.5 meter per second, right? I want you to find the equation that is for time. So this is the position equation. Let's write it down over here. This is the position. All right, that's it. Now I want to find this equation as well. 3 cosine 2 pi over t. I want to find the big T so that this become the function of time. How can I do that? Well, not so difficult. I can use the information I have. Velocity is what? Lambda frequency. So velocity is lambda over 1 over t. So velocity is lambda over t. So t is lambda over velocity. Lambda is 4. Velocity is 0.5. So period is 8 seconds. Come over here. I write t is equal to 3 cosine 2 pi 8 t. All right, now that's good. However, my goal is to put them together so it becomes a video version, not the same snapshot. How can I do that? Well, let's understand the mathematics behind it. I want to write a function that takes two input that takes x comma t is equal to amplitude cosine 2 pi lambda x minus y minus, because this is shifting to the right. For example, this is y equal to x square, right? Okay, maybe y equal to x square, right? And you want to do y equal to x plus x minus, so you want to do this, right? And this is 1. So which one would be correct? Y is equal to x minus 1 square or y equal to x plus 1 square? Well, believe it or not, this is the correct one. So shifting to the right, this one is x square, or you can say x plus 0 square, right? So shifting to the right is negative. Okay. So therefore it's negative. 2 pi over t. I want to tell you how can we rewrite this equation. Y equal to x t equal to a cosine k x minus omega t, right? And k is 2 pi over lambda and omega is 2 pi over t. Good. Now we have 8 seconds, right? Now we can go ahead and write that down. So we're going to go over here and then write that down. Y is equal to x comma t is equal to a is 3 cosine 2 pi over lambda is 4 x minus 2 pi t is 8 t. And this is the equation for this graph, but this is not a snapshot. This is like a video, if you like. So let's first find the amplitude. Make sure you notice that this is not SI unit. X is 0.225 meter. This is good. First we're going to find the amplitude. Amplitude is super easy, is sitting over here, 0.00327 meter. Just make sure you write SI unit. Next we're going to find the wavelength, right? So what do you know? Y x comma t is equal to point a sine k lambda minus omega t, right? So what is k? So let's write k. K is 2 pi over lambda. So I want to find the wavelength. Lambda is 2 pi over k. So 2 pi over k. K is how much? K is this. So k is this, 72.1. 72.1. So this is 6.28 divided by 72.1. So this is 0.09. 0.09 what? Meter. So lambda is 0.09 meter. Okay. Now after finding lambda, we're going to find the period. So the period is right here. So the period, what we know about omega is 2 pi over period. So period is 2 pi over omega. So 2 pi, what is omega? Omega is 2.7. So 6.28 divided by 2.7. So this is 2.3. So period is 2.3, but SI unit is second. Now we're going to find the frequency. Frequency is 1 over period. So frequency is 1 over 2.3. So 1 over 2.3 is 0.43. So frequency is 0.43 hertz. Okay, after frequency, we're going to find maybe velocity. Velocity is lambda times frequency. Velocity is lambda is 0.09. Frequency is 0.43. So the lambda is velocity is 0.04, 0.04 meter per second. So velocity is 0.04 meter per second. Now finally we want to find the displacement. How can I find the displacement? Displacement is I want to find the height, okay, or displacement. So height at the function of time I want to find. So x is what? X is 0.225 and t is 18.9 is equal to 0.0037 sine 70. Let's write it over here. Y it takes to input y 0.225 comma 18.9 is equal to 0.00327 sine 72.1, and then I'm going to write this thing 0.225 no, I don't want to put 0.225 minus, I'm going to use the different color, minus, I'm going to use maybe purple, so make this one purple, 18.9, so 2.7 times 18.9, no, 18.9. Okay, so this is going to give you 0.002 meters. That would be the height. That would be the height, okay, at x comma t. Once again, this worksheet, this handout, this tutorial, probably the number one tutorial in this topic, will probably help you understand something usually no teacher allow the student to understand.